So this is your test 2 review. On number 1, I put kind of a gimme problem here. Everybody wants an A in the class, right? So we've got to solve for A here. So I have A plus 1 equals 8. So subtract 1 from both sides and you get A equals 7. So that's my gimme problem of the day. Number 2 says to solve by factoring. So whenever we have two terms, the x squared term and the x term, but we don't have the constant term, to solve by factoring, you want to factor out what you can out of those two terms. So if I factor an x out, that's going to leave me with 8x minus 15. And so now I set both factors equal to 0. So I'll have x equals 0, and I'll have 8x minus 15 equals 0. So one of my answers is x equals 0, and the other one I need to solve for x. So add 15 to both sides, 8x equals 15, divide by 8. So my solution set is 0 and 15 over 8. Alright, so it's A as well. And the third problem here says to solve by factoring, and I have all three terms, but before I can factor, I need to set this thing equal to 0. Alright, so that's going to be 6x squared minus 53x. When I move the 9 over, that's going to be minus 9 equals 0. Alright, so I can split the first term up either into 6x and x or 3x and 3x. I notice that this middle number is pretty big, 53. So I'm going to put a 6x right here, and then my factors of 9 are 1 and 9 are 3 and 3, and I'm going to put my 9 right here. And the reason for that is 6 times 9 is 54. Alright, and so I'm going to go ahead and make that a minus. That would be negative 54, which is really close to negative 53. So the other factor, remember, if I put a minus 9 here, I have to put a plus 1 here. And now you just want to check and see if you get your middle term. So when you multiply the outer terms, you get negative 54x. You multiply the inner terms, you get 1x. You put those together, you got negative 53x. So you know that it factors correctly. It's factored correctly. So set each factor equal to 0. So 6x plus 1 equals 0, and x minus 9 equals 0, minus 1, minus 1. 6x equals negative 1, divided by 6, divided by 6. So one of our answers in our solution set is x equals negative 1/6. The other one is x equals 9. So that's our two answers, which is D. Alright. On number 4, it says solve by the square root method. Alright, so the square root method, what we want to do is get the 7x squared term by itself. So I have 7x squared plus 5 equals 117. Subtract 5 from both sides. When I do, I have 7x squared equals 112. Now divide both sides by 7. Alright, and I'll get x squared equals, let's see, that's going to be 1. And then, see, I have what left over? 42, so that'll be a 6. So x squared equals 16. You know, when you have a x squared square root property, take the square root of both sides. We just need to remember to put what in front of the right side? Plus or minus, that's right. So we get x equals plus or minus 4. So that's positive 4 and negative 4. So that's A. Number 5, we have 4x squared equals 60. So we want to get the x squared by itself. So we just take this, we divide by 4 on both sides first. And I'll have x squared equals 15. Take the square root of both sides. And even though I can't simplify that radical, I still need to put a plus or minus in front of it. Alright, so that means negative square root of 15 and positive square root of 15. Those are my two answers. You see that's A. Alright. On number 6, it says solve by completing the square. To complete the square, we need to have a 1x squared to start with, and we move the constant over, so I'm going to have to move the negative 9 over and put a blank where it was. So I'm going to have to add 9 to both sides, move that over, and I'm going to put a blank on the right side as well. So you take half of what's in front of x and square it. So half of 3, you just multiply 3 times 1/2, you get 3 halves. So that's 3 halves squared, 3 halves squared. Got to put that in both of my blanks. Now the left side is guaranteed to factor into x, and then look at the sign in front of the middle term, plus, and now look at the number you were squaring, 3 halves. It doesn't matter that it's a fraction, that's okay. And it's all of that times itself. So it'll be that term squared equals, now up here I have 9 plus 9/4. If you say 3 halves times 3 halves. I need to put those two numbers together. To put those two numbers together, we need to get a common denominator of 4. So the first number here, 9, doesn't have a denominator, right? So you got to say 4 times 9, and that'll give you a 36. So that's 36 over 4, plus 9 over 4. You put your 9 up there because it already has a denominator of 4. So you add those together, and you get 45 over 4. Alright, and we take the square root of both sides of the equation, and remember to put a plus or minus in front. Now that's the square root of a fraction. When you have the square root of a fraction, you can take the square root of the numerator over the square root of the denominator. Alright, so let's see. We have x plus 3 halves, because taking the square root of something squared just gets rid of the exponent, equals, and I'm going to put a little space in front, put a plus or minus the square root of 45. Will that simplify? So that'll simplify to, that's the square root of 9 times the square root of 5, or 3 square roots of 5. And then over the square root of 4, the square root of 4 is 2. So now I'm almost done, and I'll have my two answers. I just need to subtract 3 halves from both sides to get my x by itself. Now I'm going to put that in front of the plus or minus. Alright, whenever I do that, I'm going to have x equals, notice they have the same denominator. They both have a 2 as the denominator. So that means I can just make one fraction on the left side. It's going to be negative 3 plus or minus 3 square roots of 5. Now the place that I want to look to see if I can simplify is the denominator, the number in front of the plus or minus, and the number directly after the plus or minus. And I can't simplify between those three, so that's my answer. And that's actually two answers because it has a plus or minus, right? It's going to be negative 3 plus 3 square roots of 5 over 2, and negative 3 minus 3 square roots of 5 over 2. All right, so we're looking for the one that has those two answers, and that'll be B. All right, number 7 that also says to complete by the square, or solve by completing the square. So I have x squared plus 4x minus 3 equals 0. Remember, and I'm going to erase the negative 3. For completing the square, I want to move that over. You added 3 to both sides, it would look like that. and then I want to put a plus blank on both sides. The reason I'm doing that is because I'm trying to make the left side a perfect square. Alright, and it's guaranteed to be a perfect square if I take half of what's in front of x and square it. So half of 4 is 2, so I'm going to put a 2 squared here and a 2 squared here. So that means the left side is guaranteed to factor this way. Put down your x. Look at the sign in front of the middle term. It's a plus. So put a plus. And then put down the number you were squaring, which is a 2. Alright? And it's x plus 2 times x plus 2, so you can just make it squared. Equals 3 plus 2 squared. So 3 plus 4. 3 plus 4 is 7. So now I want to use the square root property and take the square root of both sides. And when I take the square root of both sides, remember the square root and the square cancel out. That leaves me with x plus 2. On the right side of the equation, I have to put my plus or minus. So I'm going to put plus or minus the square root of 7. Now to solve for x, I subtract 2 from both sides. And make sure you put that negative 2 in front of the plus or minus. So I have x equals negative 2 plus or minus the square root of 7. So that's two answers. Negative 2 plus the square root of 7 and negative 2 minus the square root of 7. Alright, so that's going to be A. I almost chose the wrong answer. You got to make sure that all of your numbers are there. I almost chose D. You see there's a 2 in front there and there, so that makes it's not D. And then C almost looks like it, except there's a 1 right there and there, so you got to be careful about which answer you pick. Alright, number 8 says to use the quadratic formula to solve. Honestly, on 6 and 7, if I was a little confused with completing the square, I'd probably use the quadratic formula, just because that's a good way to check. So the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Alright, and so before I can use the formula, everything has to be on the same side of the equal sign. So I'm going to take the negative 10x and the negative 1, and I'm going to move them both over to the left side of the equation. So when I do that, I'm going to have 3x squared, and then I'll have plus 10x plus 1 equals 0. Alright, so in my quadratic formula, A is positive 3, B is positive 10, and C is positive 1. Have to make sure we look at the signs in front of the numbers. So now I want to plug everything in. Alright, to my quadratic formula. So I have x equals negative b, so it's going to be negative 10, plus or minus the square root of b squared, so 10 squared, 10 times 10 is 100, minus 4 times a times c, so minus 4 times 3 times 1, all over 2a, so 2 times 3. So that's going to be negative 10 plus or minus the square root of, that's 100, and then you have negative 4 times 3 is negative 12, times 1 is negative 12. So what's 100 minus 12? 88. All over 2 times 3 is 6. Now I need to simplify the square root of 88. So I like to use a factor tree if I'm not sure what it'll be. So that's 8 times 11, 4 times 2, 2 times 2. Since this is a square root, you can bring out a pair of 2's. Well, you bring out a 2 because there's a pair of 2's right there. And there's no other pairs. So the square root of 88 is going to be 2 square roots of the product of what's left over, 22. So 2 square roots of 22 all over 6. Alright, so remember, whenever I get to this point, this is where I need to look at the 6, the 10, or the negative 10, and then the 2. And you can divide all of those by 2. So if I divide all 3 numbers by 2, I'm going to get negative 5 plus or minus. Now that would be a 1, but normally I don't write a 1 in front of a radical. Alright, but you could write a 1 there if you wanted to. Over 6 divided by 2 is 3. So I'm looking for the two answers, negative 5 plus the square root of 22 over 3 and negative 5 minus the square root of 22 over 3. Alright, and you can see that is going to be C. Alright, be careful. There's 4 different answers. A lot of them look the same. You got to make sure you choose the one that has the right answers. Now, number 9 has the same directions as number 8. So number 9 wants us to use the quadratic formula. So number 9, your A is equal to 1. Now your B, you got to be careful here. Your B is equal to negative 10. Don't forget that it's negative. Then your C is equal to 50. Alright, so we have X equals negative B. Well, that's the negative of negative 10. So if you have the negative of negative 10, that's going to become positive. Then you have plus or minus the square root of B squared. Negative 10 times negative 10 is 100, minus 4 times A is 1, times C is 50. All over 2 times A. So 2 and then A again was 1. Alright, so I have positive 10 plus or minus the square root of, alright, let's see what this is. 100, and then I'm going to have negative 4 times 1, which is negative 4, times 50 is negative 200. So what's 100 minus 200? Negative 100. Again, 100 minus 200 is negative 100. That's all over 2 times 1, which is 2. Alright, anytime we have a negative under a radical, remember we want to put an I in front. So that's 10 plus or minus. And then if I have an I in front, what's the square root of 100? 10, right? So the square root of negative 100 becomes 10I. And that's all over 2. Now, either split it up first and then simplify each term. That's normally how I would work this. Or you could just divide 2, 10, and 10 by 2. But I like to split it up. I'm going to go ahead and split this up and then simplify. So when I do that, I'll have 5 plus or minus 5i. And that's 2 answers. That's 5 minus 5i and 5 plus 5i. Alright, so that is A. Now the next problem says to solve by the method of my choice. This is a problem where you can use the choices or the answers down there to kind of help you figure out what choice you want to use. So if this problem had I in it, if it was a complex number, or if the answers look like number 8 up here, I would probably use the quadratic formula. But you can see they're all numbers without square roots. So that means that this will probably factor. It may not factor easily, but it'll factor. Okay? So I'm going to try to factor 4x squared minus 31x minus 8. Now the first thing that I know is I notice there's a 4 here and there's an 8 here, and the middle term is negative 31. So if I say 4 times 8, or 4 times negative 8, that'll give me negative 32. That's really close to the middle term. So whenever I factor this, I'm going to put my 4x right here and my negative 8 right here. All right, and then I'm going to put my other number in that I would need, which would be a what? A positive 1, right? Because I want to multiply the two numbers together and get a negative 8. And then I want to multiply the outer and the inner terms together and get a negative 31x. And if I multiply the outer terms here, I get 32x, right? And then I multiply the inner term, or negative 32x, I'm sorry. So I get negative 32x if I multiply the outer terms. If I multiply the inner terms, I get a plus 1x. Put those together, you get negative 31x. So that means that's factored correctly, because I do have a negative 31x in the middle. So now, set each factor equal to 0. So I have 4x plus 1 equals 0, x minus 8 equals 0. Just solve for x in each of these linear equations, and I get x equals negative 1/4. That's one of the answers in my solution set. And solve the other equation, I get x equals positive 8. That's the other solution in that's the other solution in my solution set. So look for the answers negative 1/4 and positive 8. Looks like that's going to be C. Now when I look at number 11, I look at all of those answers, then I see how they're, how they are. I probably want to use the quadratic formula, because that's not going to factor, because I have square roots in my answer and all that. So before you can use the quadratic formula, you got to make sure you have this set equal to 0. So that's 4x squared plus 12x. And if I move the negative 3 over to the left side, that'll be a positive 3. And then equals 0. All right, so I'll make 2 sets of, well, I won't make 2 sets of parentheses, because remember, we can't solve it by factoring. Or if we can, I don't know where we even start. So we want to use the quadratic formula. So my A is going to be a positive 4. My B is going to be a positive 12. And my C is going to be a positive 3. All right, so x equals negative B, so negative 12, plus or minus the square root of B squared. So what's 12 times 12? It's 144, minus 4 times A was 4 times C was 3. All over 2 times A. Again, A is 4. So that's negative 12 plus or minus the square root. I'll use my calculator right here. Let's say 144. And you could actually just put all this in a string of numbers. 144 minus 4 times 3. Now my calculator, that's 96. I believe that's going to simplify. And that's all over 8. So let's simplify the square root of 96. Usually, if I'm not sure what it'll divide into that and it's an even number, I could just say 2 into that, right? And that would be 48. And you can break these up any way you want to, as long as you break it up and eventually have prime factors. I know 48 is 6 times 8, and there's other ways to get 48, but that's one way. And then 6 is 2 times 3, 8 is 4 times 2, 4 is 2 times 2. So that's the prime factorization for 96. So we want to get, for every pair of prime numbers, you bring that number out. So I can bring a 2 out. Looks like I can bring another 2 out here. And then I have a 3 and a 2 left over. So I'm going to bring out 2 times 2, which is 4. And then take the product of the other prime numbers that don't have pairs. 3 times 2 is 6. So the square root of 96 is the same as 4 square roots of 6. All right. So this is going to be negative 12 plus or minus 4 square roots of 6 all over 8. All right, so I want to look at this number, and this number. And I can divide all of them by 4. So since I can divide all of them by 4, that's what I'm going to do. Negative 12 divided by 4 is negative 3, plus or minus 4 divided by 4 is 1, so it leaves the square root of 6, over 8 divided by 4 is 2. So my two answers are, again, you got to be careful when you're picking your answers. Negative 3 minus the square root of 6 over 2, and negative 3 plus the square root of 6 over 2. All right, so number 11 is C. Notice that the other choices have some of the numbers that we had. Some of them have a 12 in there. Some of those have an 8 in the denominator. So make sure that you choose the right answer. All right, so solve the polynomial equation by factoring. So as I look at this equation, I see everything's on one side. That's good. I also see that if you look at the coefficients, you can factor a 6 out. That's good. You can factor, because some of these numbers are kind of big, factoring a 6 out is going to make the numbers on the inside small or smaller. Also, notice I have an x cubed, an x squared, and an x. So I want to factor an x out. Got to factor out the smallest power of x. So when I do that, I'm still going to set 6x equal to 0. But whatever I get in here, this trinomial will probably be a little bit easier to work with. So you say 6x cubed divided by 6x, you get x squared. You say 54x squared divided by 6x, you'll get plus, what, 9x. And then you have plus 120x divided by 6x. That's going to be 20. All right, so now we have a type 1 quadratic. We have 6x times a type 1 quadratic. That type 1 quadratic should factor pretty easily. Since this tells us to solve by factoring, these things are going to factor. All right, so I need to split up 20. So that would be 1 and 20, 2 and 10, 4 and 5. So since this is a type 1, the way that I want things to work out, I want to multiply the two numbers together and get a positive 20. I want to add the two numbers together and get a what? A positive what? 9. Because you want to get this number in the middle when you add them together. So this is going to be 6x, and I'll make my two sets of parentheses. I'm going to put x and x. Again, we want to break up the 20. It's either 1 and 20, 2 and 10, or 4 and 5. We want to get a positive 20 when we multiply. We want to get a positive 9 when we add. So that would be 4 and 5. Put plus 4 and plus 5. That will give us a positive 20 when we multiply. And then when you multiply the outer and inner terms and add those together, you get the positive 9x. So that's how that factors. Now don't forget, we do have 3 factors. So we're going to have 3 answers. It was a cubic equation, so we should have 3 answers, even if some of them are repeated. We have 6x equals 0, x plus 4 equals 0, and x plus 5 equals 0. So this first one, don't forget, 0 divided by 6, that's 0. So x equals 0 is in my solution set. then minus 4, x equals negative 4, minus 5, x equals negative 5. Now notice that if I was to forget my first answer, if I forget about that 0, there is a choice down there that's negative 4 and negative 5. B is that choice, so make sure you don't choose B because that doesn't have the answer of 0 there. So it's 0, negative 5, negative 4. That's D. All right, number 13 has 4 terms. And the factoring we did with 4 terms is factoring by grouping. Before we can factor by grouping, we have to put everything on one side of the equation. So I'll have 3x cubed plus 2x squared. Now I'm going to move these 2 terms over. So I'll have minus 12x minus 8 equals 0. So group your first 2 terms together and factor out the greatest common factor. So I'm going to factor out an x squared. That's going to leave me with 3x plus 2. And whenever I factor out my greatest common factor out of the next 2 terms, I'm hoping I'm going to get that same thing in the parentheses, 3x plus 2. I notice the first term is negative though, so I need to factor out a negative, and between the 12 and the 8, I can factor out a 4. So if I say negative 12x divided by negative 4, I get 3, positive 3x. And then if I say negative 8 divided by negative 2, I get plus 2. All right, so the same thing is in the parentheses, so that's how it's going to factor. You're going to make 2 sets of parentheses side by side, and then in one set of the parentheses, put what's on the outside of each one of the parentheses in your problem. So the x squared and the minus 4, and then the other parentheses, 3x plus 2. So that's how that factors. Now you can factor x squared minus 4 again to x plus 2 and x minus 2, or you can use the square root property to solve. Either way, you get those 2 answers, negative 2 and positive 2. I'll just use the square root property. So set your 2 factors equal to 0, x squared minus 4 equals 0, and 3x plus 2 equals 0. Again, this first one here, I'm just going to use the square root property. Don't forget you have to put a plus or minus in front of the square root of 4, or in front of 2. That's 2 answers, positive 2 and negative 2. And then here, the other equation, I'm going to subtract 2 from both sides. I get 3x equals negative 2, divide by 3, divide by 3. I get x equals negative 2/3. Remember, that's 3 answers. Just by knowing it's 3 answers, there's only one solution down there with 3 answers. Now, I'm not saying always do that, because maybe sometimes the answers are repeated and you might just have 2 listed. But here we had 3 unique solutions, so it's got to be A. All right, number 14, it's a polynomial. We're trying to solve by factoring. Make sure everything is on one side. It already is. We just want to factor out the greatest common factor between those 2 equations. Those 2 terms. So I want to factor out a 3x squared, because I have a 3 and a 12, an x to the 4th, and an x squared. So 3x squared is my least common factor. So, or I guess you could say greatest common factor. So I want to factor out a 3x squared. That's going to leave me with x squared minus 4. Again, you could factor x squared minus 4 into x plus 2 and x minus 2, but you don't have to. You can use the square root property there. But don't forget, you have 2 factors. You have the 3x squared and you have the x squared minus 4. So x squared minus 4 equals 0. We've already solved that one. We know what that equals. We get plus or minus 2. And then 3. Don't forget to set your 3x squared equal to 0. Divide by 3, divide by 3. So that's going to be x squared equals 0. X squared to both sides. Now, we don't have a plus or minus 0. We just get x equals 0. But that is the answer 0 twice. So this is why I said you don't always want to just look at the number of answers down there. Since this is x to the 4th, I should have 4 answers. Well, I do have 4 answers. It's just that 0 was repeated. So positive 2, negative 2, and 0. And that is B. All right. Number 15 is a radical equation. Remember, with radical equations, we have to check our answers at the end. So you want to get a radical by itself. So I'm going to write this down. This is number 15. It is good to number your work. I know I haven't been numbering my work, but just so I can keep up in case I need to go back and rework a problem, it's good to number that. So I do have a radical by itself already, and I have x plus 4 on the right side. So that's good. That's one less step that I have to do. So now, to get rid of the radical, you would square both sides. So we're going to square the left side and square the right side of the equation. Here's where we have to be a little careful, though. So when I square the left side, that's fine. I mean, you just take the radical away. But when I square the right side, don't just square the x and square the 4. I have so many students that do that. X plus 4 squared means x plus 4 times x plus 4. So you have to fold that out. If you just square the first term and the last term, you're just going to have x squared plus 16. Well, that's not what that's equal to. You fold that out, you get x squared plus 4x plus 4x plus 16. So you have the x terms in the middle that you have to put together, and that's 8x. All right, so I have 18x minus 9 equals, I squared the right side, so I pull that out. I get x squared plus 8x plus 16. All right, so if you look at this entire equation, now you can see I have a quadratic. My highest power is x squared, and I have x to the first here and here. So to solve a quadratic, you want to set it equal to 0 and then use whatever method is easiest for you. So I'm going to take these two terms on the left side, I'm going to subtract the 18x and add the 9 on each side. Subtract the 18x and add the 9. All right, so now I have x squared minus 10x plus 25. And that is all equal to 0. It doesn't matter if you put equal 0 on the left side or equal 0 on the right side. I am going to try to factor this because I notice I have a 25 here, and that's either 1 and 25 or 5 and 5. This is a type 1 quadratic because that's a 1x squared. So our rules are, make two sets of parentheses side by side, put your x and x. Now, we look at the factors of 25. We want to multiply the numbers together and get a positive 25, and we want to add the numbers together and get a negative 10. So what will I need? That's right, negative 5 and negative 5. Because when you multiply those two, you get positive 25. When I multiply the outer and inner terms, I get negative 5x and negative 5x. That gives me negative 10x. So that's how that factors. Since that's the same factor, I don't have to solve it twice. So this is another one of those problems where if it's an x squared, you're going to have two answers. Well, it's just the same answer repeated. So x minus 5 equals 0. So x equals 5. But you don't write x equals 5 and 5. You don't write it down twice. You just write it down once. All right. Now, that is my proposed solution. What does that mean? that means that I need to plug this back into the original equation. So over here, before you squared anything, plug in a 5. So I'm going to have the square root of, I'm going to do this in my calculator, 18 times 5, and then minus 9 is 81. So that's the square root of 81 equals, now plug your 5 in for the x on the right side. That's 5 plus 4. The square root of 81 is 9. 9 equals 9. It checks out. Since it checked out, that is our solution. All right. If that would not have checked out, and that was my only solution, and it didn't check out, it would be no solution. But it did check out, so just x equals 5 on that one. Notice there's a negative 5 there to try to trick you, so make sure you pick C on that one. Well, make sure you pick the right answer, which in this case is C on this one. Number 16 is one with 2 radicals. So what I'm going to do, this one is a little bit longer. So I'm going to copy this one out and move it down a little bit so I have a little bit more room to work. All right, so whenever you have 2 radicals, the first thing you want to do is get one radical by itself. So I'm going to have to add the square root of x plus 1 to both sides. And when I do that, that'll move that radical over. And so now I just have this square root of 2x plus 3 by itself. So I want to square the left side, and I want to square the right side. Squaring the left side is easy. That's just 2x plus 3. When I square the right side, though, that's not something that we would normally square that you're probably used to squaring. Remember, you can't just say the first term times the first term and the last term times the last term. You have to FOIL that out. So I'm going to FOIL that out, and I'll get 1 plus 1 square root of x plus 1 plus 1 square root of x plus 1 plus the square root of x plus 1 times the square root of x plus 1 is x plus 1. So now I have 2 constants I need to put together, and I have the 2 square roots I need to put together. Now the way you put the square roots together is you look at the number in front. In this case, there's a 1 and a 1, and you just add those numbers up. And so it's going to be 2 square root of x plus 1. So I'm going to write all this over here. I'm going to write my x to the first, and then 1 plus 1 was 2, and then the square root, 1 square root of x plus 1 plus 1 square root of x plus 1 is 2 square root of x plus 1. So far, I got a radical by itself, and I squared both sides. Now, what that does is that gets rid of one of my radicals. So now, this is a radical equation that just has one radical. So it's kind of like I'm starting all over. So first thing I want to do, get the radical by itself. So I have other terms on the right side I need to move over. So you can see I have a positive 1x, so I want to subtract x, and a positive 2, I want to subtract 2. And I'm going to move those over to the left side of the equation so I can get the radical by itself. So now I have x plus 1 equals 2 square roots of x plus 1. All right, so now that I have my radical by itself, even though there's a number 2 in front of the radical, that's okay. I want to square both sides. When I square the left side, I have to FOIL that out. When you FOIL that out, you get x squared plus 2x plus 1. Now on the right side, you got to be careful because you have a number in front of the radical. So you say 2 times 2, that's 4. And then the square root of x plus 1 times the square root of x plus 1 is just x plus 1. All right, so you can see this is a quadratic equation on the left side. On the right side, I'm going to distribute my 4. That'll be 4x plus 4. To solve a quadratic equation, you want to move everything to one side of the equation. You want to set it equal to 0. So minus 4x and minus 4 to move those over. Minus 4x minus 4. So I have x squared and then a positive 2x and a negative 4x. That's going to be minus 2x. And a positive 1 and a negative 4, that's going to be minus 3. That is a type 1 quadratic. So this is the easy type to factor. And there's only one way to get 3, that's 1 and 3. Now I do want to get a negative 3, so one of those numbers is going to have to be negative and one's going to have to be positive. But then I want to add them together and get a negative 2. So my 3 needs to be negative to do that. So you have x and x plus 1 minus 3 equals 0. Now we set each factor equal to 0. X plus 1 equals 0. X minus 3 equals 0. Subtract 1 from both sides, you get x equals negative 1. Add 3 to both sides, you get x equals positive 3. Now the bad thing is those are just proposed solutions. So I need to write down my original problem again. So here's my original problem. And then I need to plug each answer in separately to see if they check out. First, I'm going to plug in a negative 1. So for x equals negative 1. When I plug a negative 1 in right here, that's going to be negative 2 plus 3 under the radical. Negative 2 plus 3 just leaves me with a 1. So this is the square root of 1 minus. Now I'm going to plug in a negative 1 right here. Negative 1 plus 1 is 0. The square root of 0, that's just going to be 0, right? And then equals 1. So I have 1 minus 0 equals 1. 1 equals 1. Checks out. So that means that is for sure a solution. Now, let's plug in a positive 3. So if I plug a positive 3 into the first radical, that's going to be 2 times 3 is 6. 6 plus 3 is 9. So that's the square root of 9 minus. Now plug in a positive 3 into the second radical. It's going to be 3 plus 1 is 4 equals 1. So 3 minus 2 equals 1. 1 equals 1. So that checks out as well. So your solution set is both answers, negative 1 and positive 3. Sometimes one of those might not check out, so it's important that you check. Sometimes neither will check out. If neither check out, it's no solution. All right, so just make sure. And if you look at the choices on that one, it's going to have all the different variations. See, negative 1, negative 3. Just 3. No solution. Negative 1, 3. So you got to make sure you choose the one that says negative 1, 3. All right, 17 and 18, pretty easy. They are absolute value equations. So remember with absolute value equations, you need to write down 2 equations. And they're fairly easy to solve. So you write down the way that the equation looks without the absolute value bars. If there's nothing to move over and get your absolute value by itself, then again, just write down the way it looks without the absolute value bars. X plus 4 equals 2. Then write down the way it looks, but make the right side negative. So x plus 4 equals negative 2. And then solve these 2 equations and you'll have your 2 answers. So subtract 4 from both sides. We got x equals negative 2. Subtract 4 from both sides. We get x equals negative 6. So your solution set is negative 2 and negative 6. And that's B. On number 18, we have to do just a little work before we set up our equations, and that's because, look at number 18, you have a plus 5 on the outside of the absolute value bars. So we need to move that 5 over. So I'm going to subtract 5 from both sides. So I'll have the absolute value of 3x plus 4. And then I subtract 5 from both sides. That's going to be equal to what? 9. 14 minus 5 is 9. So now I can write down my two equations. I write down 3x plus 4 equals 9. And 3x plus 4 equals negative 9. So solve these two. Subtract 4 from both sides. 3x equals 5. 5 by 3. Divide by 3. So one of my solutions is x equals 5/3. My other solution looks like it's going to be negative 13/3. All right, so 5/3 and negative 13/3. Be careful, that is A. Now 19 and 20 are the quadratic-like solutions. I know that it says to make the appropriate substitution. We really don't have to make a substitution as long as we treat these like quadratic equations and factor them. Now, notice there's a square root of x as the middle term. I am not going to leave it as the square root of x. I'm going to make that x to the 1/2 power because that means the same thing. So the way that I know that I can treat this like a quadratic equation is because if the middle power is, if you say it times 2 and you get the first power, then you can treat this like a quadratic equation until the very end when you're solving for x. So you make two sets of parentheses side by side. All right. Now the middle power is x to the 1/2. That's what I put first. X to the 1/2 and x to the 1/2. That's because if I say x to the 1/2 times x to the 1/2, you add the powers and get x to the first. All right, and that's what I have to start off with. So now this is a type 1. So I want to look at the factors of 50. So that's going to be 1 and 50. It's probably a lot here. 2 and 25. 5 and 10. I'm going to stop there because, and that may be all of them, I don't know. But because I want to multiply the two numbers together and get a positive 50. But then I want to add the two numbers together and get a negative 15. So if I make the 5 negative and the 10 negative, when you multiply them, you get a positive 50. When you add them, you get a negative 15. So I'm going to put minus 5 and minus 10 equals 0. So now, once you have that set up, take each factor and set it equal to 0. I'll show you how to work these out. Got x to the 1/2 minus 5 equals 0, and x to the 1/2 minus 10 equals 0. All right, so we want to get the x to the 1/2 term by itself. So add 5 to both sides. So I have x to the 1/2 equals 5. Now, when you solve for x, you want x to the first power. The way that we can make this x to the first power is by raising both sides to the reciprocal power. The reciprocal of 1/2 is 2. You say, why do we do that? Why would that make that x to the first power? Well, it's because power to a power you multiply. So this would become x to the 2/2 power, which is x to the first power. So those will always cancel out as long as you use the reciprocal. You'll be left with x. And then 5 squared is 25. So one of my answers is 25. All right, let's go to the next one. Solve for the x to the 1/2 first. Got to add 10 to both sides of the equation. So I have x to the 1/2 equals 10. Square both sides. So I have x equals, again, remember, when you multiply 1/2 times 2, power to a power, that would become x to the first. And then we all know 10 squared, 10 times 10 is 100. So my two solutions are 25 and 100. All right, so that's going to be C. All right, here's the last problem. We're going to factor this the same way. So what do I put first? We look at the middle power, right? So I need to put x to the 1/5 and x to the 1/5. Now look at the this is another type 1 quadratic. We can treat it like a type 1 quadratic. Look at the last number here, 1 and 2. That's the only way I can get -2. One of those is going to have to be positive, one's going to have to be negative. Now when I add the two numbers together, I want to get a what? A -1. All right, so I'm going to make the 2 negative then. Because when I multiply those two together, I get a -2. When I add those two together, I get a -1. So since those are my two factors, I'm going to put +1, and I'm going to put -2. Now let's set each factor equal to 0. So x to the 1/5 plus 1 equals 0. Subtract 1 from both sides. So x to the 1/5 equals -1. Now I don't want x to the 1/5, I want x to the first. So what's the reciprocal of 1/5? 5, right? You just flip that. So raise both sides to the 5th power. So the 1/5 and the 5 would cancel out and just give me x to the first equals, anytime we raise a negative number to a odd power, that answer is going to be negative. All right, so it's negative, and then 1 times 1 times 1 times 1 times 1 is just 1. So one of my answers is -1. Let's look at the other equation. X to the 1/5 minus 2 equals 0. Plus 2 plus 2. So I have x to the 1/5 equals 2. Again, I want this to be x to the first, so raise both sides to the reciprocal power. All right, those powers cancel out, leave me with x to the first. 2 to the 5th is 2 times 2 times 2 times 2 times 2. That's going to be positive 32. So my solution set is -1 and positive 32. That's going to be B.